Hi, I'm Michael Byrne, and this is my Math 12 project. It's on the topic of fish keeping, specifically water changes in the tank and how that relates to mathematics. So, I guess I've been keeping fish for a little while now, and I have several freshwater and brackish aquariums, and we're going to be looking at this aquarium in particular with the flower horn fish in it, and I'm going to show you how to do a water change. So, this is the tubes and the buckets I use to remove water from the tank. And so basically that is done to ensure that the water stays clean. So there's no buildup of nitrates and whatnot in the water, like harmful chemicals. You take some out, then you get some water from a tap, and you treat that with dechlorinator. And that makes the water safe to put back in the tank. And keeps the fish healthy and happy. So in a few moments here, I'll be showing you kind of the math, I guess, behind how often and how much water you should change. And I'm going to be talking about the buildup of nitrates and kind of how much water has to be changed so that nitrates don't build up. Okay, so each week, I've calculated that about 5 parts per million of nitrate builds up in the tank. So first off, we're going to be looking at a 10% water change each week. So what that means is for week 1, we have 5 parts per million building up in the tank, and then doing the 10% water change removes 10% of the nitrates, resulting in 0.5 being removed, and then 4.5 parts per million in the end. So then that would carry over to week 2, 4.5 parts per million, and then I will add the 5 parts per million, and then minusing the water, the 10% takeaway leaves us with 8.55. And then week 3, we take that 8.55, add 5 to that, the new nitrates accumulating, and then, of course, take away the amount of nitrates that come out through the water change, 10% of the nitrates once the two numbers are added together. So we can see that number keeps increasing and increasing, and it eventually plateaus at a very high number. So moving on to 33% water changes, we start off, and I skip a bit of the tough math here. We can see that the accumulation rate is a lot slower here. So you go from 3.35 to 5.60, and then, on from that. Now, 50%, it's a little bit of an extreme water change. Again, skipping the work, because it's just a repeat of what was done in the 10%. So we can see 2.5, 3.75, and then 4.375 parts per million. So we can see that plateaus at a very early point. So, in conclusion, if you're doing 10% water changes, you'll eventually plateau at 9 times the accumulation rate. So the accumulation rate being 5 parts per million, 9 times 5 ends up being 45 parts per million, which is a little too much to have in the tank. So moving on to 33% water changes. It will plateau at 1.75 times the accumulation rate, so 8.75 parts per million. That's not too bad. That's pretty manageable, actually. And now 50% is clearly the best one for as far as like a low number to plateau. It's actually 1 times the accumulation rate of 5. So 1 times 5 is 5. The only thing is 50% of water is a lot of water to be changing. So what I do is 30%, 33%. It keeps it sort of manageable. It keeps the nitrates low enough, saves the water. It's good on the fish. And yeah, thanks for watching my presentation. Bye.